Hey YouTube, Poopslag here, and this is TurboFat, an open source game I'm making in Godot. The source code's linked below if you want to see how it all works. But this month I was adding a new environment called Lemony Thickets, which was the second environment in my game, and it involved some pretty funky tiling logic and stuff I had to customize. And it got me thinking ahead to like, well, when I have 10 of these things, what's some work I can do now so that my game isn't a total headache to develop in a few months' time. So let's get to it. So first, I sketched out how I wanted this place to look. I got these little odd-looking trees, little rivers of lemon frosting, and these gingerbread cookies. But most importantly, this lemon frosting is alongside bare unfrosted sections of cake, and that I hadn't done before in my game, and that was so much harder than I expected. Let me get into why that was so difficult. So the first reason this was going to be difficult is the sheer number of tiles I would have to draw, because for a typical auto tiling where your neighbors could be on or off, and you have like 4 neighbors, you're talking about 2 states to the power of 4, so that's like 16 tiles, which is still a lot to draw. But I was talking about having 3 states because your neighbors could be on or off, or like on but the frosting is missing, right? So that's like this third state, which means now I have to worry about 81 tiles, which is an insane number to draw. So I still drew a lot, but I didn't draw 81. I just drew a bunch. But also Godot, its auto tiling logic doesn't know about like water or land or terrain. It just knows like this tile is next to itself or not next to itself. So if I wanted to handle this third state, I'd have to write my own auto tiling logic too. So I already had some custom tiling logic for placing invisible boundaries around places where the player couldn't walk. And intuitively, the way to add this new tiling logic would just be to expand that class to say, well, this tile map not only drops invisible boundaries, but it also drops these frosted and unfrosted tiles appropriately, and it figures out where they should go. But the problem with that is, in 10 months or so, if I have a lot more logic and maybe there's like bodies of water or roads and stuff that all need to be tiled differently, now this class balloons to be really huge. And if there's some other tile map where it's like, well, this tile map has roads, but I don't need to worry about the water logic, I can't split those things out. I can't say, well, this will only borrow like those 3 functions and not the fourth function. It doesn't play well when you start needing subsets of that logic. So there's this design methodology which says you should prefer composition over inheritance, meaning rather than being 10 things, it's better to have 10 things. That way other places can mix and match. They can say, well, you have those 10 things. I'm just going to borrow these 8 and I need those, but I don't need those other 2. So the first thing I did was I took the old implementation where this invisible object logic, before it used to be a tile map, and it had a function to refresh invisible walls where it would update itself and change its own cells. And I changed that logic to say, well, now this logic is on a node that's a child of a tile map. It'll grab that parent tile map, and it still has a function to refresh those invisible obstacles, but it'll just update its parent. And the cool thing about this design is now a tile map could have 4 or 5 of these different tilers, which are responsible for different things, and it could just mix and match and grab whichever ones it needed. So here's the frosting tiler logic I came up with. You can see, like the logic I just showed you, it's just a regular node that hangs off of a tile map and updates its parent tile map. It defines a bunch of bitmask constants for concepts like I have frosting on this side or bare unfrosted cake on this side. And then it defines a bunch of mappings which combine those constants to say that combination of like frosted and unfrosted cakes should be represented by this tile at 1.6 or whatever. And then at runtime, when it needs to auto tile, it just determines the bit masks that correspond to the current tile and then grabs the tile out of those mappings. So it's pretty simple to implement. It also updates the corner maps, which are like the little hole in between 4 tiles needs to be covered by something based on the surrounding tiles, so it just figures that out as well using the same exact strategy. And here's the results. I think it looks all right. You got when there's like frosted cake and unfrosted cake next to each other, you can see the seams line up okay and everything looks all right. There are a few tiles that aren't implemented because I did not draw all 81 possibilities, but overall, I'll just have to be careful to design my maps in a way that those tiles aren't needed. So I also wanted the maps to have some randomly placed grass and pebbles on the ground just for some variance. So I drew those assets also. I implemented them using the same tiler patterns. So they just hang off a tile map and they add pebbles or grass to their parent tile map. And those amounts are configurable with export variables, so you can play with those numbers and see what looks good. So I drew these other decorations too, like little gingerbread cookies, cream puffs, lemons, and stuff on the floor. And of course, these big trees with their different eye variations. So they can look around from side to side, and mouths, and their leaves can be different shapes and stuff like that. So when I put them in the game, I used animation players to make the leaves look like they're blowing in the wind and to make the eyes blink and dart from side to side. And I have a shuffle button in the editor, which will just randomly give it a different leaf shape or a mouth expression, so that when I'm dropping a bunch of these, it's easy to just be like, give me a bunch of different ones. And here's the results. I think they look pretty cool. So gameplay-wise, you can flip pieces by hitting both rotate keys. And a while back, I also added like a kick where it would check if it can flip in place, and then it would also try moving it left once so we could do it in a corridor. But now it has a whole flip kick table. So if it's in this orientation, you try to flip it, it'll check, and that lets you do these cool moves now where P and Q pieces can flip horizontally. I don't know if you'll ever need it, but I needed it once. So I was like, I have to add that in. So it's in now. So that's where we're at the start of April. We got this new environment, Lemony Thickets, mostly implemented. It's got stuff like the custom frosting and unfrosted tiling, and like grass and pebbles and all that stuff we couldn't really do before. Now it's all implemented in a very cool and scalable way, so I'm happy with that. The only thing that's missing are like a few buildings or landmarks or story-specific details that I haven't quite gotten to yet because I haven't fleshed out the story, but that's what I'm looking to do in April. So hopefully next month, if you'll join me, I'll have some of the story stuff done and cutscenes, and the new area will start feeling more fleshed out and have a little bit of a story to tell. So see you guys in May, I hope, and thanks so much for watching. See you later.